Hello students, last class we discussed the basic concepts of motion, rest motion and linear motion, circulatory motion, of course vibrations. So vibrations are also called as oscillatory motions. You should remember that. So we discussed what is rest, what is motion, and of course linear motion. So and after that we'll come across this word physical quantity. Physical quantity. Please note down whatever written on the board. Physical quantity. So what is physical quantity? So physical quantity means you have already heard these words: acceleration, speed, distance, velocity, height, weight. You can say that I am 60 kg. So that's your height, weight. You can say that I am 45 kg. You can say your height, I am 150 centimeter high, 145 centimeter high, 155 centimeter high. That means that is height and weight. So these all are physical quantities. Then what is physical quantity? Okay, if I give the examples of the quantities which are not physical quantity, so I can say laughing, I can say sadness. Okay, these all are not physical quantities. So then what is physical quantity exactly? Physical quantity means a quantity that can be measured. Okay, physical quantity means what? A quantity or anything that can be measured. Anything that can be measured. That can be measured is called physical quantity. Is called physical quantity. So it should be measured. It can be measured. Then only we can say it as a physical quantity. Or we can say physical quantity, that means a quantity that can be measured. See what happens. Anything that can be measured, we can call it as physical quantity. Example, what we can give? Example, what we can give? We can give speed, we can give velocity, we can say then height, we can say length, etc. These all comes under physical quantity. So these all are coming under physical quantity. So anything that can be measured is called physical quantity. Okay, so which are not physical quantity? So anything that can be measured means you can say your height, you can say your weight in numbers. For example, you say your height as 160 centimeter. You can say speed, he is speeding, he is going with a speed of 60 kilometer per hour. So you can say that. You can say the length. The length of a chalk is 5 centimeter. So you can say that. You can say distance. The distance between Mudod and Jamkand is 25 kilometer. You can put these all in numbers. ಇವುಗಳನ್ನು ನೀವು ಮೇಜರ್ ಮಾಡಬಹುದು, ಇವುಗಳನ್ನು ನೀವು ನಂಬರ್ಸ್ ಒಳಗ ಹೇಳಬಹುದು. ಸೊ ಅವುಗಳಿಗೆ ನಾವು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಅಂತೀವಿ. ಯಾವುದನ್ನ ಮೇಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಅದಲ್ಲ ಅವಕ್ಕೆ ನಾವು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಯಾವುದನ್ನು ಮೇಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಅವು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಲ್ಲ. ಎಕ್ಸಾಂಪಲ್ ಯಾವುದು ನಾನ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಗೆ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಆಲ್ ಎಮೋಷನ್ಸ್, ಸ್ಯಾಡ್ನೆಸ್, ಹ್ಯಾಪಿನೆಸ್. ಯು ಕೆನಾಟ್ ಸೇ ದಟ್ ಐ ಆಮ್ ಸ್ಯಾಡ್ 100 kilo. No, you can't say like that. Today I am very much happy about 100 meter. Can you say like that? No. You cannot put emotions under or in numbers. You are happy, you are sad. Okay? You are feeling superb. These all are emotions. These cannot be put under numbers. These cannot be measured. India won the World Cup. How excited are you? You are excited too much, but you cannot say it in numbers. I am excited around about 100 centimeter, 100 kilometer. I am excited 20 kilometer per hour. No, you cannot say like that. You cannot measure your happiness, your sadness, your excitedness. You cannot measure that. So those which you cannot measure, those are not physical quantities. So that which can be measured, anything that can be measured is called physical quantity. So anything that we measure or which can be put under numbers, those are called as physical quantities. So anything that can be measured is physical quantity. So there are two types of physical quantity, scalars and vectors. There are two types of physical quantities. Those are scalars and vectors. So what is the scalar and what is vector? Scalar, a physical quantity having only magnitude but no direction. Okay, or you can say rather than physical quantity, the quantities having only magnitude, the quantities having only magnitude. See, these scalars are having, or scalars you can say vectors. The quantities having only magnitude. These are having only magnitude, but not in direction. But not direction. So these are having only magnitude, but not direction. So that means these are having the magnitude, but direction is not present for this. Quantities having only magnitude but not direction. Vectors, the quantities which are having both magnitude as well as direction. The quantities which are having both magnitude and direction. Both magnitude and direction. See, this is scalar, this is vector. Scalar andre enu, vector andre enu. Quantities having only magnitude but not direction, or you can say no direction. It is having only magnitude but no direction, or but not direction. ಯಾವ ಕ್ವಾಂಟಿಟಿಗೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇರ್ತದ ಬಟ್ ಡೈರೆಕ್ಷನ್ ಇರುವುದಿಲ್ಲ. ಸೊ ಅವಕ್ಕೆ ನಾವೇನಂತೀವಿ ಸ್ಕೇಲರ್ಸ್ ಅಂತೀವಿ. ವೆಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ದ ಕ್ವಾಂಟಿಟೀಸ್ ವಿಚ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ both magnitude and direction. These are having both magnitude and direction, but scalars are not having both magnitude and direction. They are having only magnitude. For example, if I take the example of time. So what is the time now? You can say 2 p.m, you can say 10 a.m, so you can say it in numbers. But in which direction it is? There is no direction. You cannot say that 10 a.m. upwards, 10 a.m. downwards, 10 a.m. towards the east, 10 a.m. towards the north. You cannot say like that. You cannot say it with direction. That means time has no direction. That means it is a scalar quantity. Time is a scalar quantity. So time is the best example for scalar quantity. Then vector, which example we can give? So vector is what? It is the quantity which is having both magnitude as well as direction. The quantities which are having both magnitude and direction. Magnitude means value, and if direction is also present, then we say it is a vector. For example, displacement. Displacement is a vector quantity. Okay, velocity. Velocity is a vector quantity. You have to say displacement along which direction a body gets displaced. Suppose if I take this duster, okay, I will move like this. Okay, if I move like this, it starts displacing. In which direction is important? it is moving in this direction, say left. See directions, you can say direction left, right, upward, downward, east, west, south, north, northwest, northeast, southwest, southeast. These all are directions. Okay, so here I am applying some force. Force is an example of vector. I am applying some force that is displacing the duster. So displacement is happening along which direction, in which the force is applied? Say to the left of object, to the right of object. Now it is at left of object. So this is vector and direction. So what is scalar and what is vector? So I will write the examples here. Okay, so let me rub this first. So I hope you all are clear with what is scalar and what is vector. So first you understand the definitions, then we will see the examples. What is scalar? The quantities having only magnitude but not direction are called scalars. Example of scalars. What are the examples of scalars? Scalars example is time. Time is the best example. Distance. Okay, you can say like this. And vectors. Distance, speed. Speed also comes from this only. Vectors. What are the examples? Velocity, acceleration, then velocity, acceleration, force, weight, here mass, okay, etc. You can put etc. See, we'll see one by one how it is a scalar and how it is a vector. See, time, as we already know, time is not having any direction. You can say 10 a.m., 2 p.m., 5 p.m., 12 a.m., 12 p.m., 1 a.m., 1 p.m., but you cannot say it in direction. You cannot say 1 a.m. left, 1 a.m. right. You cannot say 1 a.m. north, 1 a.m. south. You can never say like that. So it is a scalar. It is not having any direction. Okay. Distance. So regarding distance and displacement, you will come to know next. But distance is also not having any direction. You should just remember this. Distance is not having any direction. Okay. Speed is also not having any direction. Suppose in a circular path, Earth is revolving. Speed of Earth is present. Okay, it is revolving in circular path. In which direction it is revolving? Absolutely, there is no direction. So if it is revolving, Earth is revolving like this. Say we consider actually it is an elliptical orbit. So sometimes even you can say it is in circular orbit also. So let us not take Earth. Object is moving in circular motion. So if you see here, this object is having this kind of direction. If you see from here. If you come here, this object is having this kind of direction. If you come here, this object appears to be in this direction. It appears to be in this direction here. So everywhere it is changing its direction. So it is not having any fixed direction. That means it does not have any direction. Direction should means it should have a fixed direction, a proper direction. Here there is no direction. Means here no direction means the circular motion is accelerated motion. That is a different thing. Okay, it is not having any direction. That means speed is not having any direction. So it is having, the object is having speed. That speed is not having any direction, means speed is a scalar quantity. Of course, it is moving with 10 km per hour. So let us, 10 is very less. Say 30 km per hour. Okay. It is having magnitude. 30 km means it is a magnitude, it's a value. But it is not having any particular direction. So then speed is a scalar. Mass. See, there is a lot of difference between mass and weight. So mass is not at all applying any force, it is fixed one. The mass of a body will not change. So if the mass of a duster here, see suppose around about 200 gram, if it is there, 100 gram or 200 gram, okay, it will not change even though you keep it in the moon. Mass of your body, if it is 60 kg, it will not change even though you go to moon. Okay, so mass is a scalar. It does not have any direction. Mass of you may be 50 kg, but in which direction? Definitely it does not have any direction. You cannot say my mass is 50 kg in a north direction. You cannot say my mass is 50 kg in south direction. So direction is not present for mass. So mass is not having any direction, which means it is a scalar quantity. This kind of many things are there. Okay, those are scalar. So what is scalar? The quantities or the physical quantities which are having only magnitude but not direction are called scalars. So what are vectors? The quantities which are having both magnitude as well as direction are called vectors. ಯಾವುದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಇರ್ತದ ಮತ್ತು ವ್ಯಾಲ್ಯೂ ಇರ್ತದ ವೆಕ್ಟರ್ಸ್ ಯಾವುದಕ್ಕೆ ಬರೇ ವ್ಯಾಲ್ಯೂ ಇರ್ತದ ಬಟ್ ಡೈರೆಕ್ಷನ್ ಇರೋದಿಲ್ಲ ಅವು ಸ್ಕೇಲರ್ಸ್. ಓಕೆ, ವೆಕ್ಟರ್ಸ್ ವಿಲ್ ಸಿ ವೆಲಾಸಿಟಿ. We cannot say this as velocity because it is a speed. It is not having direction. If the speed is having direction, we call it as velocity. If the body is moving in a straight line, isn't it? It is having particular direction. Then we can say that it is having velocity. There it is having both value as well as direction. Then we say it as the velocity, and velocity is a vector quantity. Acceleration again. Acceleration means in which direction the body has changed its speed. Acceleration is what? Change in velocity, we call it as acceleration. Change in velocity with respect to time. We call it that as a acceleration. So change in velocity happened in which direction? So that matters there. So that is why it is a vector quantity. Force. Just I have shown you. I have displaced the duster. I am applying some force here. So when I apply some force here, so it is moving in this direction. Okay, on the direction in which force is applied, in the direction in which force is applied, in the same direction it is moving. Or say left to the duster it is moving. So here direction matters. So force is applied in which direction, that also matters. So force is having direction and it is having value also. I may be applying 500 Newton force, I may be applying some force, some Newton force, 10 Newton force, whichever it may be. Okay, I am telling randomly. So, okay, so those force has some value also and it has some direction also. That means it is a vector quantity. Weight is a vector quantity. So mass and weight difference I will tell later. So weight is also vector quantity because weight is a force. Whatever the force I am applying on earth, that is my weight. So whatever the force I am applying on earth, or whatever the gravitational force earth applies on me, that is itself is a force. That itself is a weight. That we call it as a weight. So weight is a vector. So it is having direction as well as value. So these are regarding scalars and vectors. So I hope you all understood physical quantity, scalar and vector. So I hope you all are clear with this. Okay. So which are the physical quantities we are coming across in this chapter? See, distance we are coming, we are reading distance or we are studying about distance. We are studying about displacement. Then what we are studying? We are studying about speed. We are studying about velocity. We are studying about acceleration. So extra we will study about mass and weight also. It is not mass and weight also. So with this we will study uniform motion and non-uniform motion. Uniform and non-uniform motion, and of course we will study equations of motion and graph and numericals. Equation of motion, equations of motion, graphs, and after that there are some problems. That means numericals. So we'll study all this, but these are the physical quantities we are studying. Okay, these physical quantities we study mainly. Okay, mainly these 5 physical quantities we study. We'll see some mass and weight also. Okay, see, so this regarding what we study next. So we'll see first one in this, that is, so after this we can see uniform and non-uniform motion, equations of motion, graphs and numericals. Okay, so we'll study first one in this, that is distance. So distance can be also called as distance traveled or distance, simply we can say distance or distance traveled. The actual path length is called as the actual path length. The actual path length covered or traveled, you can say traveled. Rather than covered, this is the better word. The actual path length traveled by an object or a body, by a body. The actual path length traveled by a body is called as distance traveled or distance. Is called as distance. Okay. The actual path length traveled by a body is called as distance. Okay. It is a scalar quantity. It is a scalar quantity. It is a scalar quantity. SI unit of it. SI unit of distance is meter per second. SI unit of distance is meter per second. Formula of distance. Formula of distance is speed by time. You should remember these 4 points. Okay. So we'll discuss these 4 points. See here. First thing, what is distance? Actual path length traveled by a body is called as distance. Don't forget traveled there. It is upwards. So the actual path length traveled. The actual path length traveled by a body is called as distance. See, distance is not having any fixed direction. We can move it in, it can be moved in whichever direction it wants. So no particular direction. That means it is a scalar quantity. So how we measure it? We measure it in meter per second. And the formula of is distance is equal to speed by time. So listen here, distance is the actual path length traveled by a body. Suppose if a person or a bus is here, CA, so no, not A, this is 10 kilometer, 20 kilometer, 30 kilometer, 40 kilometer, 50 kilometer, 60 kilometer, 70 kilometer, 80, 90, 100 kilometers. Okay, so we can say distance in km. Okay, suppose a body is there, okay, or suppose a person is there in car. He takes from this point to, that is 0 to, he move to 100 kilometer. Okay, and after that he will come back 50 kilometers. Okay, so the total distance covered we have to check. So the distance here is 150 kilometers. Why? Because that is the actual path covered by it. Actual path covered is initially it went 100 kilometers and after that it came back to 50 kilometers. So 100 plus 50 is 150 kilometer is the distance traveled, isn't it? So the total distance traveled, so the total distance traveled is how much? 150 kilometer. See here, distance is equal to speed by time. Okay, sorry, distance is not equal to speed by time. Sorry, speed is equal to distance by time. The formula is, if you have written, please change that formula. Speed is equal to distance by time. Okay, that is different formula. So distance is equal to, we can write it as speed into time. You can write. So distance you can measure it in. So the SI unit of distance is kilometer or meter. The SI unit is considered as meter. So distance we can measure. What is the distance between Jamkhandi and Mudhol? 25 kilometer. So for commercial, for big units, we use it as kilometer. But the SI unit that distance is having is meter. Okay. Actually, I have written the SI unit of speed and I have written the formula of speed there earlier. Okay, reverse formula. So that is why speed is equal to distance by time, or distance is equal to speed into time. Okay, that you remember. And SI unit of distance is what? Meter. So how the distance is? It is the actual path length covered by an object or a body. The actual path length traveled by a body is called distance or distance traveled. Both are same. Distance or distance traveled, both are same. What is distance or distance traveled? It is the actual path length traveled by a body. It is called as distance. It does not have any direction. So it does not have any direction means what? It's a scalar quantity. So SI unit of distance is meter. Formula distance equal to speed into time, or you can take speed is equal to distance by time. So this is regarding distance. I hope you all are clear with this concept. Okay, next class I will discuss about displacement and I will brief about distance, and we'll continue with the displacement. We'll see the difference between distance and displacement, and if possible we'll see speed and velocity also. Okay, we'll continue the things in the next class.